Yes, please.
Would you like to take it away, or should I take it away?
Good afternoon. Welcome to TVR Working Group. So we're about to get started. I'd like to say thank you to our outgoing AD, Andrew Alston, and welcome to our incoming AD, Gunter Vandeveld. This is our Note Well slide. If you're here at IETF, we're listening to you. You are responsible for the things you say. These are the conduct guidelines we expect you to abide. Summarize, don't be a jerk. These are all the bits and bob. Help yourself. And here's how to run Meet Echo. If you don't know, it's already Wednesday, so you've been doing this all week already. We need a minute taker. Can we please get someone to take minutes? These are our outstanding milestones. As you can see, some of them are past due. We're working on it. Okay. So here are our outstanding documents. The use case document, this is now at Rev 9. This is, actually, this is now instantly out of date. This has been followed up and is now on the RFC editor queue. So this is about to be published. Yay. We are almost done with our requirements document, and we will be probably trying to do a working group last call very shortly. And finally, we have our schedule document. This has been discussed. We have a few more iterations to go on this for sure, but this is probably ready for working group adoption. And we should discuss that when we come up to that presentation. Here's our agenda today. We are not tight on time, so feel free to use the time to discuss. And we do have a bunch of open mic time at the end if people want to discuss other things. Jumping in.
Start with requirements. Welcome.
Thank you. Thank you, Chairs. So this is Luis from Telefonica, and I will present in this occasion the draft about requirements on behalf of my co-authors and all the contributors to the document. Next, please. So the intention of this draft is to collect and yeah, basically, essentially to collect all the requirements or about the time variant routing concept. So from the charter, the objective of the document was to document the TVR definitions, requirements, nodes, rationals, and examples. Sorry. For doing that, we are basically looking at the use case draft and also collecting some other inputs and also reviewing some other aspects, and as I expect to refer to them during the presentation. So, but essentially based on the use case draft. Next, please. So, time variant routing, as stated on the abstract, refers to the calculating a path or subpath through a network where the time of message transmission or reception is part of the overall computation. So how understanding what is the impact of the potential schedule changes that we could have along the time. So for that, we consider network topologies that could be either or could have either intrinsic topological changes or occasional topological changes, but always predictable changes. I mean, that are scheduled on the time, and so how we have some notion of anticipation to these changes, either intrinsic or occasional. That could be the case of topologies where we have limited resources or connectivity, or situations where we can identify changes on the links, or that the changes that could be topological, or changes that could be associated to cost, as could be financial, environmental cost, and so, and also situations due to mobility. But again, not random mobility. So somehow that we can associate some idea of prediction to those changes. In essence, situations where we could have losses of links or new links, but also, again, just as a remark, in a predictable manner. Next, please. So, regarding the scope of the document, the idea is to define topology changes and departing from IETF technology concepts when possible. So in terms of proxies, nodes, termination points, links, and so, and only defining new capabilities when needed. So, but the reusing all that we could found existing on IETF. We will discuss requirements based on use case scenarios, as said, and these scenarios are the ones related to resource preservation. That could be the situation of energy preserving the energy consumption, operating efficiency. So, for instance, consequence of workload migration, the fact that we could maybe reduce the topology footprint, maybe making some links going in the switch of mode, for instance, or also the dynamic reachability. That could be the case of the satellite scenarios, or some other scenarios where the topologies are changed dynamically, but in a predictable way. So the document also defines a number of concepts about visibility of the schedule changes, locality, where we will comment a little bit more on the next slides, but where the changes are generated or executed, and then some notions regarding the temporality in general. And these are referring to the time variability concept, time horizon, time precision, periodicity, continuity, interpolation, and so. So aspects that are related to this temporality notion. Just very briefly commenting, for instance, the time horizon. So what is the horizon of these time changes that we are considering? The precision of them, so the different granularity in terms of timing, the periodicity, so what is the kind of sequence of changes that we can face along the time, the continuity of those changes, so is infinite let's say, periodicity, or is somehow that we have a kind of rule for when these changes will happen, and interpolation in the sense that between two different changes, if there is a need of interpolating values, because we could have, in a sequence of changes, we could have some values predefined for the different events, but if there is no need of having some other intermediate value, what could be the interpolation that we can consider. So all of this is part of the document. Next, please. So the progress from the previous version that was presented in IETF 118, there is a further general discussion on generation locality and execution locality. I will go through that later on. We added also some requirements in different aspects. For instance, the freshness of the schedule. So just to prevent that some schedule that could be age somehow could impact the reliability of the system. Also, the fact of maintaining the schedule consistency in different deployment scenarios. We also were to discussion of the deployment scenarios, distributed, centralized, or hybrid usage. The impact on the routing protocols and the use of netcom fast schedule update mechanism. Then we discussed as well about schedule identity. So we need to identify who is generating the schedule or not. That's just for security considerations. We will comment later on that. We also refer to managing schedule changes. If the changes proposed could be partial or full or so. So also the implications of that. The document now uses PCE language. We refer several times to computation, so this is related to that. Security considerations, we have started that, but this is a part that is very relevant and probably devotes time to be sure that yeah, what could be the implications that we could have in security terms, so avoiding attacks, avoiding misbehaviors, and so. Finally, we remove as well the mandatory conformance language. All this should, must, and so we clean up the document in that direction. In this exercise of refreshing the draft, there were a lot of open issues that we were discussing among authors and contributors, and all of this is registered in the GitHub. So please go through that, and you can see the different point opens, and if you consider something new should be taken into account, please yeah, propose that as issues. Next, please.
Before you go on, I just do have a question with Chair Hat off. When we talk about the impact on routing protocols, these are not requirements or constraints that are being levied onto routing protocols. These are configuration or deployment impacts. Can you speak a little more to what do we mean that we are impacting routing protocols?
Yeah. So the idea would be to understand what else should be considered as the routing protocol if we introduce the scheduling capabilities on them. So let me, I'm trying to figure out now one specific example of what we are considering that. Yeah, we are referring in the sense of considering that could be intrinsic to the routing protocols, the way of managing the scheduling changes, or that could come from I mean, not intrinsic to, I don't remember now the exact word that we are using, sorry for that. Intrinsic and extrinsic, I think. So yeah, the implications that could have to have these variability capabilities to the routing protocols themselves. I think that we will comment later on more in terms of where we are generating the considerations of generating the impacts or the executing the impacts. I think this is related to that. Probably we can comment on the next slide on this.
Okay. Understood. And then with Chair Head, and that makes sense. And then we just want to make sure that we don't have requirements on other routing protocols as part of this document. That would be a negotiation with other areas.
That's the point.
Thank you.
Thank you. So next, please. Yeah. So part of the discussion is about the generation. So where we generate the time schedule changes, right? And here we can consider two ways of generating the changes in a centralized manner, where basically all is done in a central orchestrator that's somehow later on synchronized with all the devices and inform the devices about what could be the changes, the schedule to apply to the routing changes, or distributed in such a way that are the different devices, the one that generate by their own with the information that they are collecting, the changes to be applied to the routing. So this will be about the generation of the changes to be produced. And next, please. Then we have the execution locality. So where the changes are from where the changes are applied. Again, this could be executed centrally. So from the orchestrator to be informed to the devices what are the moment in which they need to change the schedule, the routing, routing information, or distributed so that the changes to the routing is done by the network nodes themselves. So again, recapping, the generation that could be centralized or distributed, and the execution that could be also centralized or executed. Here, for the execution, will depend on the capabilities of the routing protocols for incorporating the changes themselves. So it could be the case that the routing protocol has intrinsically this capability of producing populating the changes, let's say, or it could be the case that not. So depending on that, also we will have these different possibilities. Okay, next, please. So we also, during our discussions, we were considering some other aspects that can also impact somehow the scope of the requirements. One of them is the multi-domain case. You can see list there three different assumptions that we did, but probably the one where we could have more discussion is about the multi-domain. So essentially what we stated is by now we are working the requirement document thinking that the routing and the scheduling information, everything is constrained to a single administrative domain. Okay, so that there is no multi-domain case in this requirements document, at least by now. But we are leaving out of the scope, so it's a matter of discussion in the working group. If we assume the multi-domain, where either the scheduling or the routing could come from different domains, or we just are constrained to the single domain case. By now, we are considering the single case domain. Then also, we added as an assumption that we are not covering the random mobility events. So we are covering mobility events as in the charter, but those that are predictable in advance, so not random at all. And also we leave out of the scope of the document whatever impact that could has to do with changes on the addressing of the nodes and so on. So these are the assumptions that we are putting now in this version that were not in the previous version. So I will comment that towards the end in the conclusions if we what to do with the multi-domain case. So yeah. Next, please. So regarding the content of the document, yes, we highlight these distributed, centralized, and hybrid scenarios. As mentioned before, we could have decentralized or distributed generation and execution of the changes. So these deal with two different scenarios, distributed, centralized, hybrid. We also include some ideas of implications that could come from LEO satellite routing considerations. There are a number of drafts that somehow serve us to source for having these considerations. And issues consider constraints that require for time variant path computation, either distributed or centralized, as said. Schedule updates, distributed or centralized, if the schedule is partial or full, the changes that we should consider, and also the interval changes. Also, discussion on distribution of a schedule using IGP, and updating of the schedules via orchestrator, basically that. More detail could be needed for this, so yeah, probably could be nice to have a kind of interim session or basically using the GitHub for having more discussion on this and collecting the views for the working group on these assumptions. Next, please. So we also spent some time on the security considerations where we were thinking on this, and there are several considerations to be that could have a potential impact on all the TVR stuff, right? So things like denial of service attacks, so that malicious parties could manipulate or disrupt the time information, could be a serious attack. Also that the TVR information could be used for having traffic analysis or route prediction, for predicting network activity, for identifying user activity, or for even other situations like time spoofing or resource manipulation. So these are serious aspects to be considered. And yeah, basically we started to draft this section in the document, but for sure we require more elaboration and probably identification of further attacks that could be maybe the clock itself, and that could somehow create a very bad situation once we are working with this time variant routine stuff. Next, please. So as next steps, we would like to agree on the assumptions that we have taken. The multi-domain probably is the more important one to understand if we constrain by now the analysis to the single domain. Also, further discussion is needed for the control plane implications, the satellite requirements, or looking at those drafts, existing work, or any other contribution that could come from the working group. The aspect regarding to topology management, the computation should be also a matter of consideration in the time that takes that computation as part of the information taking, and so on and so forth. Also, further discussion about the schedule identity and verification. So, is every party allowed to propose some changes on the routing? We need to identify who is proposing the changes, who is scheduling what is the actor proposing the schedule. So somehow trying to securitize as well all these parts. And operational considerations. So how to manage the TVR schedule between peers, if we need to consider trust models, and also what could be the impacts on clock synchronization, if we can assume that from the beginning that the clock synchronization will be fine, or we need to do something to ensure that we synchronize the clock before starting to interchange messages for changing the routing. So these were the next steps, and I think that this is the last slide. So yeah, any feedback is more than welcome, and for sure we encourage collaboration.
Kenji, CMCC here. I try to think about this is like a more general TVR case. And then I'm thinking about like the satellite, normally called like a NTN, non-terrestrial network. We'll consider everything together here and talking about the end-to-end, basically like a hybrid or integration of TN terrestrial and and NTN. So it seems to me this one, well, for all the requirements, seems you're only focusing on the TVR itself. That's just my my observation. Should you also add something like the integration, the TN with the TVR, non-TVR and the TVR, something like that?
Yeah. So certainly we have been focused only on the TVR stuff. One of the discussions that we had for the NTN and the satellite interaction with the satellites and so was precisely going in the direction of the multi-domain. To one extent, we can consider that everything is on a single domain where we consider the satellites, or this open the multi-domain case. The multi-domain has implications for how to trust the information and how to trust all the potential changes. Probably could be different approaches to that. So if there is like the nature of the satellite is the changes in the topology are predictable themselves, probably there is not a need of interaction between administrative domains, then that would probably could be easily covered here. But if we need to have a kind of interaction between domains, then we open the discussion on multi-domain and all the complementary aspects of the trust and so on and so forth. So yeah, I think we need more discussion as a working group where we put, let's say, the frontier, because from that frontier we will derive some impacts on the requirements that we will need to work on. Thank you.
Okay. Lee is in the queue.
Li Zhang from Huawei, and one comment. Yes, in time variance scenarios, we also always assume that most of the topology changes are predicted, but sometimes maybe the predicted information is not very correct. So maybe I think we can add some more descriptions on the node how to deal with when the predicted information is not consistent with the actual status. Yes. Okay.
Yeah. Thank you for the question. I think in the charter is clear. We assume that the predictability. I'm not sure what would be the room for having some estimated predictability. So clearly random changes or not predicted well changes are not considered, but something in the middle, not sure to what extent we can assume what kind of accuracy on the predictability could be part of TVR. We are talking in the requirements about the accuracy of the clock and the synchronization of the clock. That is specific to the clock signal, let's say, not to the time, but that accuracy on the time estimation. Again, I don't know where would be what would be the frontier to what we consider something predictable or not predictable. So maybe it's a matter of discussion of the working group itself to understand where we put, let's say, the threshold.
And Rick is in the queue.
quick audio test. Can you hear me?
Yes.
Yes.
Oh, excellent. Just a comment on the multi-domain aspects. I put a comment in the chat. My gut tells me that you're doing the right thing by focusing on the single domain requirements, because I think it means this document can get written, completed, and through to the IESG in a sensible rate. And then with that understanding of the single domain problem, then the multi-domain aspects can be tackled at a later date. A suggestion would be to make that really clear in an early section of the document, to say, this is the scope of this document. We understand there are multi-domain problems, but we're not going to tackle them now. This is a building block towards a later document.
Okay, thank you for the feedback. Now we state this in the introduction, the assumptions that we take, but probably we can reinforce the message. Yes.
And I have one more question to this, but it is a question really out to the working group, and maybe we can do a quick show of hands. I'd like to know who has read this document. There's been quite a bit of work on it. I know that we've had a good discussion on it in the past 2 or 3 prior working groups. But if we feel that we're getting close to complete on the major issues, let's find out who has read it. So this is the first one I've done this time. So let's see. Say read requirements document. How's that? So, all right, we are active. This, that's right. We can round up to yes. If you have read the relevant parts of the document that you are interested in, maybe. We'll let that just go for another couple seconds. All right, so it looks like about a third, a little more than a third, perhaps. So my request is, because this document is maturing and nearing completion, as Rick mentioned before, we would like to get this through in a reasonable rate. If you have not read it, please take some time to do so. And if you do have additional questions, please take it to the mailing list.
Thank you.
And then we have one more.
Don't go away.
We're friendly.
You're up for Alto, yes?
Yes. So we would, the next one, just back to back on the agenda, is using Alto for exposing this information.
Thank you. Thank you. So hi again. Yeah, I will present this other draft, which is about the usage of Alto for exposing TVR information. Next, please. So just as a recap of what is the proposition here. So the Alto protocol, which is an IETF outcome, incorporates a capability which is called cost calendar, that allows to expose different topological views along the time, right? With different schedule timing, let's say, associated to them. So the idea of the draft was essentially to leverage on that capability for proposing an off-path mechanism to advertise these changes of topology. So the diagram shows an exemplary case. Could be, I mean, the focus is not in the case itself, but the possibility of having Alto with this cost calendar way of exposing information. And essentially, what here the use case that is represented would represent an intervention in a network where a technician identifies a schedule change along the time, and with that, okay, we can somehow infer the changes or the impact of those changes in terms of not only topological changes, but also KPIs, like occupancy of the links or latency or whatever, and then you feed this information into Alto in such a way that Alto can expose that to external applications. Here, the mode of this would be that external applications could have an insight of what could be the impacts of the changes. And this could be, for instance, as an internal CDN of the operator or whatever, that with that information can decide later on what to do in terms of, for instance, injecting the stream flows in the network. That would be more or less the case. Next, please. So the advantages of this approach, so essentially with leveraging on this off-path capability, we can offload the processing of changes from the network elements itself. So it could be a centralized component like Alto or the network controller, the one understanding the impact of those changes. Then also, this approach allows to consider predicted changes due to the appearance of new nodes. So we can, in that process of understanding the changes, we can just simply feed the fact that there will be new nodes in the network or new links or whatever. So this all is done from a decentralized component in an easy way, basically. And also allows, because of the off-path nature of that, allows to expose this to applications to external consumers. For sure, can be done also for internal consumers. If we are thinking, I don't know, mobile packet core or whatever, that can be done. But I mean, could be used for internal and external applications. Next, please. So the changes from the previous version, we did some fixing of the editorial document itself. We continue to do the assessment of this proposal against the TVR requirements. In this case, versus the version 01, because the version 02 was not yet ready. And basically confirming that more or less is aligned with all the requirements, except one of them, which is about the overlap of the topological changes, because this is not allowed by the cost calendar functionality of Alto. And this, just to comment that the draft has been already presented in IETF 117 and 8. Next, please. As next steps, we would like to collect further feedback from the working group. All the previously received comments has been already addressed, so we think that is ready, and we would like to ask adoption as a kind of off-path solution for TVR. And that's all. Thank you.
And Peng is in the queue.
Only from China Mobile, and I see in the draft there's in the architecture there's a network digital twin, right? So I want to ask that, is it necessary in this architecture?
It's not necessary. I mean, the focus is not on the digital twin. At the end, we will need some component that do the prediction. I mean, that's on how is able to run the what if scenario, because what we need is to collect the impacts of that change in the future, right? We exemplify that with the NDT. In fact, we are doing some implementation with some NDT, but it's not the focal point of the draft. The focal point of the draft will be to leverage on the cost calendar capability of Alto for exposing those changes, independently of how these changes are, how the effect of those changes are produced. That could be network digital twin, could be the network controller itself. I mean, these planning tools that are available in the market, so it will be whatever other tool.
Okay, thank you.
I forgot to mention that we are implementing this use case. Hopefully for next IETF will be open source release of this case. So hopefully we can showcase that.
Since, with the chair head on, since there is a request here for working group adoption, which would be an adoption poll on the mailing list, while we are here together, are there any, is there any comment on adopting this document from we who are present, either in person or online?
Kinji, CMCC here. It's not regarding adoption. I try to understanding some part here. You're proposing use Alto to do the management, I think. The thing is like, are you going to unlimit Alto only, or have you sort of like to integrate Alto in your case with some other, well, suppose you called some other controller, and that controller can do management work for other domain, and then such that you can integrate this one together. So I try to get okay. Are you consider like some general off-path solution? You know. Yeah.
Well, in this case, we propose Alto tactically because Alto already incorporates the cost calendar feature, so it's very straightforward. For sure, I mean, whatever other component, let's call it, that could have this cost calendar could be equally applicable, but Alto being an outcome of IETF and incorporating this functionality seems to be very straightforward. So the integration with other components, for sure, one basic integration will be with the network controller for retrieving the current status of the topology. So collecting that with IETF topology YAM model, for instance. So we need to understand that that is a component for exposure, not for actionate the network. For actionate the network, we will leverage on the network controller. For instance, if there is any change to be introduced or the predicted change will be done always by the network controller. Alto is just a component for exposing. And yeah, because it incorporates also this cost calendar functionality, so it's very straightforward.
Any other comments before we move on? All right, thank you very much.
Thank you, thank you.
All right, our next presentation is routing considerations for satellite constellation networks.
Oh, thank you. This is for the
Slides.
Oh, okay.
Maybe. We'll see if it works.
Yeah.
It'll work? No? No?
Hang on.
No?
Well, maybe I need to be, try it now?
Let's see. This is what?
It is.
You've already complained.
Yeah.
Yeah,
No, that's okay.
It's
I
okay.
can-
Well, yeah, just I have only a couple of slides. Well, I can talk a lot.
Click it by raising your hand and then. I
Okay,
can-
sure, no problem. Yeah, thank you. Yeah, here is like thank you. Oh,
Oh, sorry. Do I get back?
yeah, Louis, thank you for giving very general description about the requirements for the TVR. But in this case is specifically for the satellite part, because this is the work with my colleague Peng and also some other partners from FutureWay. Yeah. Okay, well, this is the, I try to use some real use cases from the 3GPP, because I involved in that organization also, and that organization has done quite a few standard work on how to use the satellite to provide all kind of services. So this one is the previous release of the 3GPP on how to use satellite to provide the access and the backhaul service. But at that moment, it's called a transparent service, meaning there is only one satellite that's going to provide a very simple case. And then the GNOB, or the base station, as we all know, will be on the ground. But just depend on where do we put. One is like satellite access, the other part is the backhaul. And then the onboard equipment, onboard means like almost satellite equipment, will only do very simple things like frequency conversion or signal amplification, those kind of things. So for that things, it's very simple. There's no like a routing consideration since you have only one. And then the onboard equipment can only do very simple, the layer one things. So that thing, although has been, it's like a trigger case, but there's not much interest for the IETF, from IETF point of view. This work has been concluded by 3GPP last May, like 10 months ago. Yeah. Can you go to, let me go to the next one. Okay, good. Yeah, this is a really challenge that comes out from the current work. It's ongoing in 3GPP right now for the satellite case. This time it starts to use the regenerative. But regenerative means like the GNOB will be onboard the satellite. And the core network might or might not be. But the thing is, if it's on the onboard some satellite, and then it's going to involve the ISL link, the inter-satellite link. And also some service, the 3GPP people are discussing to put some edge services on board different satellites. So if you put everything together here, and then you get a satellite network that's going to have like the GNOB on board, the core network on board, even the 5G control, a lot of network functions on board, even some services. So here it's like, I have a picture about here. The bottom left picture is showing a specific case for the release 19. So far, it's ongoing 3GPP right now. It's called the store and the forward. So what it means like for some client or UE or your like your iPhone, your Android phone, that can send the text message through satellite. That is, by the way, that link between your UE, your phone, and the Genobe onboard, that satellite called the service link. That link is available, but the other link is from the Genobe toward the ground station. That is called the feeder link. So the 3GPP is investigating if both links are not available at the same time. So what can be done? Okay, so that means you do a text message. That text message will be stored somewhere on board, somewhere. And then the satellite will start to move around until the satellite can detect their ground station at some place somewhere. At that moment, it's going to do the downlink, the transmission from satellite to the ground network and then send. Okay, this is like by the way, on the other direction, the text message reply from other users or from the on-ground user can send it back. So just consider a reverse path. This is like the scenario for store and forward. Now, get some very interesting part about the thing, because for the wireless world, when you have a phone that going to register with the network, the wireless network, in wireless network, the authentication and authorization is very important. So there are a separate process or procedures like a registration management process, RM, like a connection management, like a session management, all kind of things. And then there are like the user will have subscription record stored someplace somewhere. Well, based on the different proposals, that record might be saved, stored on ground or saved on satellite. Okay, now the thing is, so look at the bottom right picture here. That picture, well, I borrowed from a proposal from the 3GPP. That is still being discussed, not being concluded yet. So if you look at for that picture, toward the up left corner, at that moment, your phone is connected, that is service link connect to one satellite. But that satellite is not connected to a ground station that is on the bottom right. So it's a diagonal point. So in that case, the phone, okay, will go through some registration, but it cannot finish. Okay, and then the satellite will start to move toward using the clockwise, going to the top right, and then go to the bottom right. At that moment, the satellite can connect to the ground station. Okay, and then it's going with some exchange messages. Okay, the process will be done, at least remember, this is just a one way yet. And then the satellite will continue moving and toward the clockwise direction, and then going back to the original part, the top left, and then that is like a one round trip. So it seems at that moment everything cool. The RM part, the registration management, the connection management, or even the session management can be done at that moment. But the thing actually, yeah, can you go to the next one? Yeah, but actually it's not, because even if the satellite moves back, but remember the Earth is rotating. So well, just again, well, I put in the draft some mathematical calculation. So on the equator, when the satellite moves back after for the LEO 95 minutes, actually the UE has already moved away like 2,600 kilometers already. So it's way beyond. So the satellite cannot find the original UE. So even one round trip is not going to work in this case. So the proposal or the solutions in 3GPP, okay, basically say, okay, we have to use ISL, multiple satellites, which will be connected through inter-satellite links. And then in that case, when the original satellite cannot find your phone, the UE, and then it will pass those the contacts to some other satellite, and then those satellites will help with the work. So this one is
the proposal right now. But so it's still being discussed. The reason I used the previous case and this one to show this is a real scenario, and then we are in 3GPP discussing right now. In the 3GPP, though we do acknowledge this is critical, but in that particular issue for the store and forward, we put one architectural assumption. The assumption is ISL is good, it's critical, but it's out of scope. It did not say, okay, it's the scope of IETF, but it's actually is implying. Okay, yeah, can you? Okay, so for that things, that is just I paint a big picture about okay why I'm here, and then no, I did not just give all the things, all the details in the draft. I just left list here some restrictions. The first one is very dynamic of routing topology. I will not go into cover this one because everyone knows it because the satellite are moving there. The second one is like the limited bandwidth of peer links. This one actually are using two real cases. One is the second case actually is public information. Oh, should I answer that? Or after that?
It is your preference. Would you like to?
Yeah, let me finish one, and then we'll be, since we have much time, we can discuss toward the end. Okay, so the second use case here actually is a published case. Our company launched two satellites, and then one running the GNOB, the other running the 5G core network. And then the measured the rate for uplink is 5 megabit per second. The downlink is 1 megabit per second. While the ISL can run at 230 megabit per second, but they still but this not sufficient. The third restriction is the hardware limitation and the reduced capabilities. When you consider harsh environment and the temperature, the near vacuum, radiation, all kinds together, and then it's kind of a challenge environment. And then I just list some challenges here related, because of that satellite environment related to the routing part. So this is like 3 restrictions we listed here also in the draft. Next. Okay, so this is the continuum part. Okay, that is a restriction, but for the satellite, what do we have? The first one is the uniqueness is like the trajectory of the velocity of satellite, or footprint are predictable. So everyone knows it. That one actually can be determined, in advance. Well, the terminology we use like ephemeris, something like the height, inclination, azimuth, time change the tracks, all kind of things. It can be predetermined. The things here actually in the 5G, the 3GPP release 18 is already used the things. Well, I can give one example is like I call it SCAI, satellite coverage availability information. So basically to help with the discontinuous coverage or non-discontinuous coverage, those type of things. So meaning, so you have a UE, you have a phone, want to connect it to get a wireless service through the satellite, but the satellite may move. So you can do some in advance to do the calculation to say, okay, the satellite service will not be available in, I don't know, maybe like 1 minute, 2 minutes, 5 minutes, and then it's going to be available in 1 hour, something like that, based on ephemeris. And then for that moment, for that period, as the phone, you do not want to waste your power. So you can put yourself in the power saving mode, like EDRX, extended discontinuous reception mode. So such that your phone can last longer time. So that one is being used already in the spec, the standard of the 5G. So I just gave saying, okay, that is very useful. I believe that is also useful, for the routing part, well, the satellite routing things. So when put everything together here, we listed 3 design principles in the draft. The first one is like, since there are no full set of routing intelligence on satellite, it cannot. Actually, it does not need, because it has some good information to use, okay? And also it has the reduced capability on the hardware, red cap hardware. And then it can also to simplify the traffic forwarding logic based on for the onboard satellites. For this picture is from our a published paper from last October with my co-authors. And then the design principle for the final one is like actually I asked in Louis' presentation about, okay, well, for the NTN and the TN, because for the wireless, when the wireless side, and then the things like you are trying to like a broad networks through the satellite, actually you are going to have the TN, and the TN on the ground station is going up toward the NTN, and then on the other side, the NTN might go to TN. So actually, it's like an integration of the TN, the terrestrial network, and NTN non-terrestrial networks. So that's why I say, okay, well, based on our consideration of kind of things, based on our experience and the normative work from the 5G, we propose, okay, well, maybe we are using layer. One thing is just like the regular IGP, because for those things, for the node on the ground, they can do whatever they want. But on the ground, the station is like a gateway towards the NTN. That one will have its own. It's like the NTN routing domain. It does not you have a full-fledged routing. It can have you some determined information for these things. Okay, I think that the next one. Yeah, well, yes. So basically, this is the thing is like we have put. This is the draft 00. This is specific for the satellite. I know this TVR is more general, a big umbrella, but this is for the satellite because there are some use cases from the 3GPP, and the 3GPP also is doing the standardization for the release 19, but that one has some assumption. The assumption is out of scope of the 3GPP, but that scope actually in our view should be the IETF. So yeah, welcome the comments. Thank you.
All right. Thank you for your patience.
Yeah, sorry about that. Yeah.
Yes. Hi, Dan Bogdanovich. Could you please go to slide number 4? No, no, one more, number 3 then. Where's the graphics?
Yeah,
this one.
Yeah.
This one, yeah. So that was okay. So in your lower left diagram,
okay,
you have a GNode B on board and with the IUPF that can be on board with the same one, or it can be on a different one.
Right.
IUPF is used for a local, can be used mainly for a local breakout. That means if I have same mobile devices that want to communicate directly to lower the latency, I can see that use case being useful. And then as you have to shift between that would be fine. But you were talking about authentication and authorization.
Okay.
There, I don't see how you can finish authentication and authorization if you're changing satellites.
Okay, very
because
good.
It has to be on the authentication vectors are being sent to one authenticator, and it have to stay with that authenticator. If you don't finish it, you have to restart the authentication process, and the new authenticator has to request the new authentication vectors.
Okay, good. Thank you. That's a very good point. So far, there are 2 types of solutions that are being proposed to handle the wireless authentication and authorization. One thing is to make the UDM, UDR on board on some place. So, but that is the challenging part is first the UDM is very large, the huge, that is thing. Okay. No, remember, this is still the proposal.
I know, but UDM on board, if you put it on every board, you haven't increased your security vectors, security vulnerability footprint, because
yes,
you have all
yes.
the security data on every single board.
Yes, no, not average. Things like the centralized, like the AV. So at the end, you're going to get authentication vector. Okay, what we're talking about the 5G here, the AMF is going to, AMF, the control plane will be also on board on some place. It's going to access to the UDM to the UDR, which is someplace on satellite. Okay, for that part, it can finish. The challenge for this algorithm so far is out of sync with the onboard, on the ground database. That is the challenge. The other type or category of solution so far, Okay, or this type of solution has not been agreed. It's still being discussed. The other solution is to integrate the registration CM and SM, but this are going to change the 5G spec for sure. But the thing is like, instead of to do one shot for the RM and then the AMF, okay, it's going to tell the UE, say, okay, pause in some status, just like RC inactive, but here not RC inactive, may something else that to be defined by the RAN team, the RAN working group. So on when the satellite move to another location that it can be connected to the ground station, that one will be done. So yes, that is a good thing that have been discussed. The other thing regarding the IUPF, good times, okay, yeah. The other thing regarding the question of the IUPF, that is also very good point. But the thing here, this is the solution proposed to handle both the uplink and the downlink text message. So because of the service link, the UE part, or the ground station part, the feeder link may not be available at the same time. So for the uplink or downlink, the text message has to be saved, stored somewhere, someplace. So for these things, okay, in order to have a consistent way to do the storage for text message, so the IUPF is there for the uplink. So the things that the text message will be saved on the IUPF. For the downlink, there another UPF will be on the ground. So the IMS, when the IMS message is routed from the N6 to that UPF will do the storage until the feeder link available. So here we have the IUPF and the PSA UPF to get a consistent way to store this type of things. So that is more details on how the solution in 3GPP is going to work. But that it does have a purpose to be put there.
Okay. All right. Thank you very much. And Tony.
Oh, okay.
Next slide, please. So one more slide. So I'd like to speak to point 2 here about bandwidth. Yesterday, you and I had a discussion, and I found a public reference, so I can tell you now that Starlink ISLs are 100 gigabits.
Okay.
Okay,
Yeah.
so there's plenty of bandwidth to run things like routing protocols.
That 100 gig between, or is that toward the ground station?
That is ISL. I cannot speak to ground station links, but
okay.
It would
Maybe, they might have something else, but the things what we have tested is like this. Yeah. So probably I remember you said you have better data, but that is, we can, okay, sure.
Ran Atkinson. Let me suggest you read the Jeff Houston's IEPG slides from Prague, which have measured data for Starlink up and down. And the short answer is lots of bandwidth.
Thank you, but next in queue. Stong Yu.
Oh yeah, by the way, Starlink, last year, same time, IETF maybe 16, there was one satellite workshop, set meeting during IETF, and we did try to invite Starlink, but they were not going to standardize. So no matter how much they can provide, they're not going to standardize. So we have to do the work here, not with Starlink.
Okay, thanks for the presentation. Dong Yuan from the T Corporation. And briefly, I got 2 comments. And firstly, that I may admit that LEOs compared with higher orbit satellites, they got natural advantages of low latency because they're more closer to the surface of the Earth. But the key or significant problem that we need to handle is that the relatively high velocity compare relatively to the surface. So there may be many academic discussions like the virtual routers configured at the orbits or some other mechanisms. And the second comments I want to discuss, that is,
there will be, here we mentioned predictable changes and unpredictable changes, variations, failures, or degradations. So I want to say that what will be the border of the capability for our conventional routing protocols, dynamic routing protocols. So they may handle this kind of unpredictable changes. So is there a necessity for them to both do the predictable changes, or this will be just preloaded?
The thing here, well, it's not like preloaded because the border part so far, you remember there's just like the draft 00 for the routing consideration thing, the border or the boundary between TN and NTN, so that we have the predictable like ephemeral information. Those can be preloaded because the satellite you're logging today you have 100, tomorrow you get 1,000. It might tomorrow has something, but there will be the launch schedule, and then you can always preload those information. That's the first. The second is actually there is some other way for the dynamic load up. Well, because the data from 3GPP side, it does have some way the out of band channel to have the dynamic ephemeral information loaded down. Yeah.
Okay, thanks.
Sure.
Justin to NVIDIA. So we are on right slide. You're talking about restriction, and there are few data points, right? The limited bandwidth, we can argue whether it's in tens or hundreds of gigabits, it's in megabits at least. ISS or SPF, the bit line protocols, they've been designed around 64K links, and they run really, really well. We all remember this. So if you are to mention restriction, I would really like you to put bandwidth at which ISS is not going to work for you.
Okay, the good point. But since if you can do something for free, why you want to waste your bandwidth for routing? See, the thing here, you have those like predictable information, right? And then you can do the pre-calculation. This one can be like an add-on. If you do have it, yes, that's good. But since this just argue from another point of view here.
So, but again, rather than having this hand wave statement, it's not good enough. Waste need to be significant. If it's insignificant, it's not a waste. It's just insignificant.
Yeah, but here,
let me provide second point, and then we can discuss it. Hardware limitations. I have my Mac laptop running flat L2 with 10,000.
Yeah.
So running SPF at 40 milliseconds.
Yeah.
So, but where's the limitation?
And you
here?
put it into like a minus 200 Fahrenheit. It's going to still work?
Absolutely.
I don't think so. Minus 200 Fahrenheit. Your Mac still going to work?
My CPU on the Mac can potentially work.
I don't know. I think it's like from the, I forget it, 40 some Fahrenheit up minus like, I don't know, minus 5 up to 45. It's already beyond the regular operation.
So I don't think we should be discussing it here.
Yeah,
My point here, if you're coming with hardware limitation, please express them in number of clocks, frequency, something that doesn't work, so we can actually, as a working group or engineers, discuss whether it's a real limitation. Otherwise, it's a hand wave.
Right, exactly. Well, I agree with you. Actually, there's something. Remember, there's still 0, and then I'm just trying to share my opinion, our opinions with the group. Yeah.
Sure, it's probably just a hint how to populate 0, 1 with tangible data points. Otherwise, that's not a restriction. It's your opinion, right?
So just to jump in with I think we. The discussions related to time variance are very important, and the 3GPP does have large questions around architecture and spacecraft hardware, and they are assumptions, and that is the point, is to document the assumptions and then evaluate them to see if they hold. But that is our focus here, is on the time variance.
Right, because the satellite is also like a time variance, like a thing, specific case under the bigger umbrella. So.
Okay. Next in queue, please.
Okay, Jidong from Huawei. Yeah, I see you mentioned on page 6. Maybe can you turn to page 6?
Page 6.
Yeah.
Oh yeah.
Yeah, you mentioned the adoption of a 2-layer routing structure, right? But here you mentioned maybe using different switching or routing scheme in these 2 layers. Do you mean to introduce something different from the existing data plane?
No. The
Or-
things like just here give a general concept about, okay, for the TN plus NTN, what are the best practice to do? Adoption maybe is like a proposal, something like not the adoption of the working group. It's just like something we were thinking in our draft to say, okay, this is like a two layer. One is from the TN part, the TN terrestrial. The other thing is like for the NTN. That is called a two layer, not to try to change the routing, the current routing protocols right now.
Okay. And here the overlay and underlay seems a little bit different from what we used to with the existing maybe 4G, 5G. Usually we have the underlay using as a TN, and the overlay is for the 5G services, right?
Oh yeah, or it's just like I try to say, okay, well, on the NTN part you have your TN and just like a well, whatever to jump from the one side to the other. It's like the overlay. Well, the infrastructure is the NTN, the satellite. So it's the underlay part.
Yeah. So this is a different.
Yeah, just this is not the official terminology. Just try to show the thing.
Okay, thank you.
Go ahead. Okay, Jenny.
Hello, I'm Jenny from APL, and I just had a general question on the intention of this document. I know you made a comment earlier on the requirements document, so I was wondering, was the intention sort of just that TVR, when they're writing out the requirements and updating, that they keep this in mind, or was there a hope that there may be a separate requirements document specifically for routing?
I do not have very specific target, but the thing is the list is like one example or some, although it's very influential example and the big umbrella of TVR. Okay. So we believe there's something unique for the satellite. Well, that is a TVR is more general. Mm-hmm. So it's not like into the same document.
Okay, yeah. I see. Gotcha. Yeah. Right, sure. Thank you.
Thank you.
Dan Bogdanovich. So if you're asking about making correct routing decisions based on TVR between the GNOD B and the UPF, this could fit within the requirements of this working group. And I mean, it is a GNOD B has to figure out to which UPF to route, depending on, and then it's which one's coming. I don't know. This one use case that I could see. The other ones, I don't see other use cases.
So I think that's an important question. I will certainly answer with chair hat on, and maybe with other chair hat on. There's nothing currently in the TVR charter to talk about the creation or the specification of routing protocols. Right now, our current charter is to understand how we model various kinds of schedule and time-related information. And from that perspective, these kinds of use cases out of SA1 requirements are useful to look at to see whether our existing requirements document covers these cases. And if the requirements document does not cover these cases, then we have learned something for our requirements document. I think that is the initial great value in this work.
I don't think there you need routing changes for this. This is just another use case where you could apply TVR to the existing routing protocols in order to solve the problem.
So last I checked, this is the IETF, and fixing 3GPP is out of scope.
No, it's I disagree with you. It's not this. This is just a use case that being investigated, and then they believe this the thing that needs help from the IETF is out of scope from 3GPP.
GNOD B and UPF to me are just IP hosts that have to have IP connectivity. I'm not looking what application 3GPP applications are running on top of that.
Exactly.
I'll say.
Go ahead.
I'm sorry.
No, you're first.
With the routing working group chair had on the work on architecture for low orbit satellites. We started this work already in routing working group a couple of years ago. Tony presented day before yesterday his approach to that. They well support the group. They seem to be significant interest to do this. So work on routing architecture will be probably or hopefully happening in routing working group.
Okay. Actually, for that picture, There's a paper behind that one, and there are like 2 or 3 IETF drafts already behind it, talking about prompt statement, the routing, and address semantics already.
I'm Rand Atkinson. So my understanding is that T-Mobile US has already demonstrated connectivity from commercial off-the-set 4G, 5G handsets at the 1900 megahertz band to Starlink in orbit. So it seems to me there is a existence proof that there's not really a problem here.
Yeah, the things like for that one, I don't have the details, but what I have learned, that is a transparent mode. That is the first slide. I talk about it. It's not a regenerative things. That one does not involve the ISL routing.
Thank you so much for the discussion on this. The last point I'll make on it is that there is a liaison between the IETF and the 3GPP. The 3GPP does look to IETF at large for standards to their problem.
It's not yet, because this one is still on the study phase. But the study phase is going, okay, this is an assumption. This work needs something, but it's out of scope right now. The study will be done by May and conclude in June this year.
The last request out to the group is just if there is something interesting in this use case that is not represented in the requirements document that is the adopted work, please take that to the mailing list.
Sure, thank you.
Our last presentation is the Yang model for scheduled attributes.
Just want to say one word about the use case. We do in the use case document, we do have satellite routing. Yeah, it's just this the one case you just presented provide more details. The use case document has it as one use case of TVR.
Could we have quiet in the room, please? If you have a conversation, take it outside. We're waiting for you.
Okay, so this one, I'm gonna present a brief update of the schedule Yang model. My name is Ying Zhenqu, so I'm presenting on behalf of all the co-authors. We done a presentation at last IETF, so what have changed since last IETF? The major thing is we were told there is this IETF schedule Yang document defined in the ops working group. That's you can consider it's at IETF level trying to define a general schedule that can be used by anything that with a schedule. So TVR is considered one of the use case for them. And so they provided some groupings for different levels with different details of schedule definitions. We look at them and we are currently using one grouping from that draft. I'll show you guys some details later. So right now we still have our own TVR schedule definition. That one we are using the grouping from the IETF schedule.yang, and we augment that model with some TVR specific requirements, and it meant to be used by TVR related models. So right now in the draft, besides the base one that defines the schedule, the major part is we have these two models. One TVR node Yang module that's the device model that meant to be, you can use it, for example, to configure a router with some schedules. And then we have the TVR topology Yang model. To my understanding, that mainly meant to be used, for example, by a controller. Your controller get a topology-wide information. So for example, you're in some interface with a scheduled maintenance window, something like that. So your controller can do some pre-calculations or manage your traffic based on the schedule. Okay, so this one is the IETF TVR schedule grouping we have. And that one makes use of the IETF schedule.yang. You can see we use the recurrence. And based on so that one defines a list of, defines an instance of schedule that can have recurrence. And what we have here, we make it, we add a list. So you can have a list of schedules. A list can be, you can have one or more schedule. And we also have that's the key is the schedule ID. We did add a schedule ID so you can, that can be used as an index. And we also added a container that can be used by different TVR attributes. So for example, if you have two interfaces that's going up and down, your maintenance window have exactly the same schedule. You can put both interfaces into this one container, or you can have them separate. That's really up to your use case. So based on that, I'm just going to show you what, after we expand the grouping, what we have here. So far, you can see it has defined the start time, the duration, and the frequency of that, the instance of that schedule. And we had a meeting with the IETF schedule.yang authors. So Don and I were there yesterday. We had a discussion with them, and because the IETF schedule.yang module, they are trying to define a very general purpose schedule. And there are some information we think might be a little bit complicated for us. So for example, the time zone. So the question here to the community here is, do we really want to support a time zone, or is UTC enough? So if we just support UTC only, it's simpler, but you will have to use UTC time only. The time zone make it more flexible, but that also means complexity, right? So another thing is, so for example, right now the duration is use a regular expression, and the TVR schedule or young model authors, we talk about this, we think seconds, the duration expressed in number of seconds is good enough for us. So we are, our point of view is we are trying to start from a simple schedule that meets our requirement, can do the machine-to-machine communication, and we try to keep it simple. But if you have a different point of view and different requirement of this schedule, please speak up or email us. So we, at the very early, we need to make the requirement of this schedule very clear. So what we talk about and what our understanding is, we try to make it simple. So it's already expressed there. And with the IETF schedule.yang authors, they will carve out a grouping specifically for us. So right now we are thinking, we will gonna change the start time to UTC only. That also means the boundary, like you define your schedule until what time, that will also be UTC only. If you think you need more than this, please speak up.
And then having said that, we do have someone in the queue.
Yeah, I think that's.
I didn't know if you were soliciting feedback slide by slide or at the end. I can wait.
I think I just hold on. Can you?
Oh, okay. Just a moment then.
Yeah, and I think that's pretty much what we have, and we really want to make sure we understand the requirement. Make sure that's exactly what we want to define.
Okay.
Please.
Eric Klein. Yeah, thank you for going back to the slide. In my personal experience, time zones make everything worse.
Yeah.
Everything worse. 100%.
Exactly.
And not only that, date time start is not a good name. If you want it to be UTC, you should call it UTC start time so that it is perfectly unambiguous. It cannot be my local start time or some other start time. It is the UTC start time if that's what we want. And I would recommend that is what it should be called.
Yeah,
Something to
we'll
that,
make that suggestion.
something
Yeah.
with UTC in the name, so it isn't. Yeah, thank you. And then I guess sorry, I am not completely up to date. What is the difference between interval and duration? Is interval the inter-schedule spacing,
Which interval? Which
or
one you are talking about?
just below frequency and above the recurrence bound? What is interval?
Oh,
Because I mean I tend to think of the interval as like the start time plus the duration. So I'm not quite clear if it's the same thing.
That's the grouping defined in the IETF schedule. Young. So right now we may consider remove that one. That's the work going on between the authors of this draft and the grouping definition. Right. So that's what I meant. We talk to them and they are going to just write one grouping for us, one simple grouping. Of course, that grouping can be used by other models if they want to use just a simple schedule. We didn't want to use with like a very complicated start time and like, for example, you can do every Monday or 1 month, like a first day of each month, those sort of thing. We try to keep this simple.
If you want to keep it truly simple, you can get rid of all of the recurrence logic altogether. And if you want to recur something, then something schedules it. The control system schedules it recurrently.
Yeah, you are saying just one slot after each other,
Yeah.
right?
If I want something to happen every Monday, then on Sunday something says do it tomorrow, and the next Sunday something tells me do it tomorrow. You know, rather than tell me to do it with a recurrence schedule. If you want it to be truly simple.
Yeah. So this right now, this one, although it has this recurrence, that's what they are grouping right now is. It's possible you define only one recurrence, so that makes it a slot.
Yeah, you could clearly have recurrence but ignore it and do it. Yeah.
Any more questions?
Thank you.
A few more. Up is Zhang.
Sandy Zhang, ZTE. I just wondering some overlap issue because if we use many schedules for on one interface, on a spatial interface, maybe in some schedule they said you should up, and in some schedule it is said you should down. So maybe the schedules may be overlapped. So how do we know if we should do for the interface or node? So for the overlap case.
Okay, so if you configure your router, say, okay, I have two schedules, schedule 1, schedule 2 at exactly the same time, two different things. Which one would you prefer, the later one or the router cannot pick one, right? It's really up to the management. If you say, theoretically, if it's up to me, your schedule 2 should overwrite your schedule 1.
Yeah, and now we know that one interface can be used in several topologies, right? So maybe I think
topologies.
Yeah.
So one interface in
can
several
belongs
topologies?
to or slice or something. Some other technologies can use one physical interface.
This is physical status.
This is logical interface or physical interface.
So right now, it depends on your model, right? So for example, you have a interface. It can be up, but it's also an OSPF interface. Your OSPF interface can be down, right? So for us, the TVR schedule, the use case we talk about, it might be related to resource saving or related with your energy. Most likely it's the physical status, but we can also know if it's really a routing interface, that's a separate module. It's a schedule.
Okay.
So the one here is the physical status.
Okay, okay. So I think it can be used for logical interface, right?
So but
Logically.
the thing is, if your interface is done, your OSPF interface is done.
Okay, okay. Thank you.
And Brian Sipos.
Hello, Brian, CPAS APL. I did get some feedback on this. I think this is a good starting point, and I gave the feedback on the mailing list. One thing that I think would be valuable, both for this and for the TVR requirements, would be to relate some of the behaviors here to those aspects in Section 3 of the TVR requirements, to be able to explain some of the choices that were made here in those terms that we're trying to define. I think that would help both documents.
Okay, points taken. And I'll look into that and add a reference pointer for that.
And Vishnu?
Pawan Viram, Juniper Networks. I just skimmed through the draft. In the topology augmentation that you have schedules under the links. You have the schedules per different for every different metric. I think you have bandwidth and then delay. Is the intention to have it for every possible metric? What is the use case there? What are you trying to do with it?
You are talking about the metric in the topology model, right?
Yeah, right.
Yeah, that one we are currently using the metric from TE model. We sort of use the type defined in the TE module. We borrow that one. So this one is mainly for like a specific link you may have if it's related with cost. So for example, with time varying cost, you might be some high bandwidth sometime, lower, relatively lower bandwidth some other time. Is that what you are trying to ask?
Yeah, I mean, right now you just have bandwidth delay. I mean, the question was, are you going to extend it to other metrics as well, or is there a more generic way of doing it?
That's the next step, right? So right now we only have very basic definitions in both the node module and the topology module. We are trying to get this schedule thing clear first. And then later if we want to add one more attributes with schedules, we'll just add more.
Okay. Another scoping question. The schedules are applied only at the node and the link level, or also looking at maybe a component level?
It can be at component level. In
And
the
that's a
draft,
different model?
in the draft, I do have an example using OSPF protocol. So, if you are talking about like TE, that can be done later.
Thanks.
Yeah.
And one more, Christian.
Hi, yeah, is duration an end time for the daytime start?
The duration right now is like how long your schedule lasts. So for example, you start at 8 o'clock tomorrow morning, it lasts for 1 hour.
So it's the end time to the start time.
Right. Yeah.
So the comment, what we did was we have a start and end time in the geolocation Yang model, and we ended up going with date time, the Yang date time type.
Okay.
For the start and end. It has a couple, well, first you want the resolution of your start and end to be the same, right? So by picking a date time for both of them, you automatically get the same resolution. The other nice thing about date and time is that it has, it doesn't specify units, right? So it's specified seconds with a fractional extension after. So it sort of just is, you're
Yeah,
not
I
stuck
see
with
that.
640K, right?
Uh-huh.
If you need it to be better in the future, it can be. So that I just wanted to point you at what we ended up going with geolocation in case you wanted to refer to that.
Okay. Yeah, I will think about that. Yeah, the number of seconds might not be ideal if you have it like hours or days of very long duration intake. Now, if we use number of seconds, it becomes a very large number. Yeah. Okay. We'll think about it. And so, although there are still some open issues, the authors believe this draft is on the right track, and we'd like to request working group adoption.
So similar to the question we asked with Alto prior to an adoption poll on the mailing list, while we are here together, are there any comments or concerns related to adoption of this document? Okay, thank you very much.
Thank you.
We do also, since we do have a little bit of time remaining, we wanted to, before we hit open mic, open the floor to Andrew, who is our outgoing AD, to talk to us for a minute.
Yeah, I just wanted to say thanks very much to the working group. It's been great, and thanks to the chairs who've done a superb job. And yeah, I'm handing over to Gunther, and I'm leaving you guys in good, solid hands. So thanks very much. It's been much appreciated.
On behalf of the chairs, we'd like to say thank you, Andrew. Appreciate your service.
We do now have, before we adjourn, any open mic comments, issues, or go backs? If not, our duration is 30 minutes less, and have a good rest of the day. We'll see you in 1:20.
Yes,
Oh, it is. Then we are on time, right? There's
1 minute over.
We're 1 minute over. I stand corrected. My schedule has not been synchronized. Thank you very much.
You had an
Oh, there's the puns we were looking for.
Oh, awesome. Oh, his name is Chen Jing.